Hi everyone, I'm glad to be here. So just a little introduction. I got into the service-to-self business, quite a long time ago, but the last year I've spent a lot of time researching and trying to better understand and to improve it in MIT, Kerberos, and in Samba. And that's basically the result of this research. So first of all, we'll try to explain why service-to-self protocol extension is important, and then I'll try to explain how it works in the normal case and in the cross-realm case. I'll mention some CVEs which came out of this work, and a couple of words about service for user to proxy and resource-based constraint delegation, which is basically cross-realm service for user to proxy, okay? Constraint delegation. Why is service to self important and why you should care? Basically, when a server gives any kind of service, be it a file server, web server, etc., mail server, the service needs to do. The service gets some input from the user. The input can be a Kerberos ticket, an NTLM challenge response. It can be a certificate that the user has proven that it possesses the private key, and it could be whatever. It could be many things. You can think of everything, but the authentication itself is just to prove to the service that the user is who he is, and that's basically the main purpose. However, as part of the authentication, the service also needs to know more information about the user. It needs to know the list of groups that the user is member to, which including the nested groups. And this list of groups is available in the token, and the token is provided to the service along with the authentication. The way it works. So let's take first of all the common usual working cases, okay, which is the ones that the most common is NTLM and Kerberos, and they are mostly used today, I think, in SFU protocol. And for HTTP, for instance, Kerberos authentication is also often used, but not using the token in the HTTP case authentication. So usually when an authentication process takes place, we need to get the token. So let's try to describe how it works in all this kind of authentication. So for instance, if we start with NTLM, so in the NTLM case, the user provides the username and a challenge response to prove that it has the password. And in this case, the server has no more information but this challenge and challenge response. So and the server also doesn't know how to verify the challenge and challenge response because the server does not. It's not a KDC. It doesn't have access to the keys. So basically, it needs to communicate with the KDC to verify the challenge response. And as part of the KDC response, it also gets the token. So it gets the list of the user, the list of the groups, and then it can apply ACLs as normally. In the Kerberos case, it works the other way a bit differently. It starts by the user itself requesting a ticket from the KDC, and this ticket contains the list of the groups, and this token is encrypted with the server's password, with the server key, and and once the server decrypts this ticket, the server gets authenticated list of the user of the groups of the user, and the server does not need to, in this case, to contact the KDC to verify it. It already has the verification and it already has the list of groups. However, this works for Kerberos and NTLM, but there are other authentication methods, and many times there is interest to develop new ones and to make new options which are still interoperable with the Windows API and still can get us a proper token to make proper ACL decisions. So for these cases, there isn't really a solution outside of the service to self as far as I know. in order to get a proper ticket from Microsoft. And the point is, Service-to-Self, the Kerberos extension, is not just another authentication mechanism. It's not like NTLM or Kerberos cases where there is a new kind of data that we get from the user, and we have a way to authenticate and to get the list. The point I'm trying to emphasize is that Service-to-Self is generic because it does not require anything from the user. So we can implement. It is possible to implement using this extension many of other authentication protocols and use the Service-to-Self extension to complete the process and to get a token for the user. So how does it work? It's quite simple. It doesn't require almost any special permissions. I think I could say it doesn't require special permissions in other directory for service to make a Service-to-Self request. The only thing that is required is that the service is a service. It has an SPN. And to my understanding from reading in Samba's source code, the reason for that particular logic, why do we need an SPN? Why do we need an SPN in order to be able to get ticket? The main point is that the Service-to-Self protocol. Okay, sorry. Let me just describe the Service-to-Self protocol, how the exchange works. So the server requests a ticket in the Kerberos protocol. It requests a ticket for self, meaning he is the client and the server in this request. Okay, and so in order to request a ticket for some service, for some account, this account must have an SPN set, and the reason for that is per the explanation in Samba source code is that if a normal user if we would issue tickets to a normal user, basically the user's passwords are often very weak, and if we will issue a ticket to them, then this ticket will be encrypted with a very weak password, and people will be able to make brute force attack against this ticket to recover the original password. So by default, Active Directory does not allow you to get a ticket to an account that is not specified as a service account, which does not have an SPN, for this particular reason. Because we believe that a service has a random key and not a big, long, secure key, and not a very easy one to try and brute force. And so I was saying that there is no real requirements, and the only requirements from a service to perform this request, the service request, is to be a service and to have an SPN configured for it. There is a note about LDAP. The usual way that people do authentication and group membership is LDAP. But I think one of the reasons I'm here right now talking about this subject is because I was working in technical support, and I was responsible for authentication and VPN. But the authentication part got me to really hate LDAP as authentication. And to my understanding, any implementation that does that in cross-realm doesn't do it properly. And even in a single realm, I think LDAP authentication is not adequate, and the way to use it is not the way to solve the problem. So as I mentioned, the consensus of Samba mailing list, it's been discussed several times, and the way to get around it is a Service-to-Self extension that I've described before. And in this extension, again, I will describe a bit more. The service can request a ticket on behalf of a user without having any. There is no any requirements to receive anything from the user himself. So all we need is basically the name of the user, and that's enough. And once the server gets this ticket on behalf of the user, then it can apply the ACL and give the user the permissions that it has. Just a little note which I'll for what I said before, that there is no requirement for service to self. So some people often think that in order to do service to self, the special permissions are needed, and technically speaking, it's often believed that the ticket received must be affordable in order to perform service to self, which doesn't really make sense. Anyways, the common understanding is that service to self requires special permission, and this isn't the case. That was the main point that I was trying to make. With service to self, we also have the support of enterprise name in Kerberos Active Directory. I think I was introduced to enterprise name on the Samba mailing list some while back, and it is quite interesting the thing you can do with it. But the main what it makes very easy is, for instance, when you get a username, let's say the simple example, you get a username and you have authenticated the user somehow. Then many times there is a lot of code on the service side in order to understand the name, to decompose it, to make UPN out of it, in order to use it in different protocols. And the fun part with enterprise name is that any combination that works for login on Windows, netBIOS/name, UPN, all these kind of names, they just work, and you don't need to worry about it. And therefore, the front-end service doesn't need any logic, it doesn't need to parse anything, doesn't need to combine the name, to split it, to do all the nasty things that we did to the names in general. It just needs to send that name to the KDC and let the KDC figure out who's this user, and this makes the front-end code much straightforward. So that's the enterprise name, and one of the other additions that the protocol supports, it supports also you can perform the service to self based on certificate. You can authenticate the user certificate, verify that he's got the correct private key. Once you have the certificate, you have no idea who the user is. You just send the certificate to the KDC within the protocol, within the service to self protocol extension, and the KDC figures out how to parse the name and what to take from it and how to make the lookups and all this kind of stuff. So that's another layer of complexity, parsing certificates, which you can save and delegate it, defer it to the centralized Kerberos domain controller. So that's another improvement. The certificate, the implementation of the X509 certificate, it wasn't implemented in MIT. I mean, the function did take the certificate, but nothing worked, and I've implemented it a couple of months back. It was a lot of fun. I found some interesting flaws while doing so, and I should point out, as I will point out throughout the whole lecture, that there was very little documentation on the MS-SFU about the X509 certificates, especially in course realm. There is a whole section that's missing. In the correspondence with Microsoft recently regarding the service user bug that I will talk about later, we also discuss this issue that the documentation is missing. They have opened a thread with me about this, and I did try to complete the documentation a bit, but it didn't work very well, and I didn't get any answer on that on my documentation change that I suggested. Next, the last sentence is something that I believe should be done and can be very helpful for many consumers of Samba to have service to self implemented within WinBind, so that services can be more free and to use some kind of different authentication mechanism rather than NTLM and Kerberos. So how does it work? We mentioned before that the process in local realm is quite simple. The KDC, all that the service needs to do, it needs to request a ticket for self on behalf of that user. But how does it actually work? So the way you do it, you just send a normal request, a normal Kerberos request, you asking a ticket for your account name as the service name. But you add a PA data to the request. A PA data, the way I think of PA data, don't try to translate the name because that would be very confusing. I just think of them as headers, and you have the headers and the body, and often the authentication will occur in the headers, the authentication material. So the way you do it, you add a new PA, you make a normal request for self. We just add this PA for user to the request, and I think that's it. And when the KDC processes the request, it verifies, it looks for this PA data, and then he understands that the request wasn't meant for the user. It was for the service. It was meant to be on behalf of the user. So there is the first PA data, the PA for user, and then there is another one, a more modern one, a newer PA data, and a newer header type, if you will, which is called SFU for X509 user. And the difference is that this PA data also supports the certificate case that we discussed, that I mentioned before. I should point out that unlike what is mentioned in the documentation makes it sound as if the service for user to self is when you have the username, and service for user X509 is when you have a certificate. But there are advantages. But first of all, the second one, the newer one, the 509 user PA data, also supports name. It doesn't require to use a certificate. Okay, that's one point. So you could use that for both cases, unless you suspect that your server doesn't support it, which is the case of Hemdal KDC. It doesn't support the second one, it only supports the first one. But there are other advantages to the X509 user. One of the advantages that I can name is the fact that the PA, the second one, the newer one, there is also the same PA data that's returned from the KDC to the user, and it is signed as well. So the return name is protected. Okay, we use that logic in MIT in order to protect the cache. We didn't get too much into the details of the security properties of service for user to self itself, but the fact was that we saw that if I manipulate the a little introduction. The Kerberos Protocol is quite confusing, and I think what's the most difficult part is to understand what part should be encrypted, what part should be authenticated, what part don't need to be authenticated or encrypted because we can figure out, we can protect it in another manner, for instance. There are some examples of that. So specifically, the returned username in TGS reply, when you request a service ticket and you get a return username, the return username returns in clear. Okay, you get the ticket and you get the return username in clear. Okay, and someone in the middle can change the return username, for instance. It's not a security problem because the name that we save the ticket with is the name for which we will create the AP request in the subsequent request. And this name must match the one inside the ticket, which is encrypted. So if somebody manipulated the ticket on the way, I will save the wrong name, but once I will try to use it, I will get an error. It won't work because the name that I use for the next request must match the one inside the ticket. So one of the advantages of the newer PA data is that the client name is returned in the same PA data blob, and it is returned authenticated, signed by the KDC. So in MIT, we use that information to save to make sure that the return in clear ticket is the same as the one returned within the signed within the PA data before we save the ticket, so that we avoid cache population. If somebody changed the name all the time, then I just keep saving the tickets, the cache will grow. Cross-realm service for user to self. Okay, sorry, I have to rush. So the cross-realm is quite more complicated to implement. It requires some back and forth connection. It's a bit more complicated. Currently only implemented in MIT. Handle doesn't support the cross-realm. I have made one of my first work on this subject was to make a pull request MDAL into Samba at the time to support service to self in cross-realm. But this is quite, I mean, the code was quite work in progress and early stage, and there's a lot of work to put in it, but I mean, the PR is still open, and if I don't get to it, if someone wants to do it, well, enjoy. So as I said in the to-dos, there are, I think that for the SFU, it will be important to port the advanced SFU code for MIT, like the cross-realm and the service user X509 user, okay, the certificate one, the newest one, the newest PA data. And on the MIT side, well, there is a lot of test coverage that needs to be added, and also to verify the use case of service to self within Samba. So this is an example ticket. This is an example Kerberos ticket. So this is a TGS request. As I said, these are the PA data, all the headers. Okay. Oops. The second one shouldn't be there. I think I used the wrong traffic capture. I used that. Yeah. Anyways, that's not a normal one. This is the PI for user that I mentioned. This is very simple. As you can see, there is the name and a checksum on the name so that it won't be, it can be manipulated on the wire. And this is the 509 PA data, because Windows client will send both, MIT client as well, because you don't know what the server is supporting, so you try both of them. And then you have the request body. And this is the request body. I should point out something that I didn't know back then, something that I learned quite recently, is that unlike the headers, which are not authenticated as part of the request, the request body is authenticated. As you can see, one of the first headers is the PITGS request, which is the TGT, okay, the TGT ticket. But the TGT ticket also comes with an authenticator, and this authenticator also authenticates the whole request body. But I guess it cannot authenticate the headers because it's a header itself or whatever the design is. It just doesn't authenticate the headers. And you will see in the next slide the consequence of that. So as part of this work, we found quite a few problems, CVEs. The first one I worked with Andreas. It was two crashes, because I should point out that MIT does not support currently SFU within Samba, the MIT build. We have code to disable it. But there was some calls for a policy check for auditing. I don't remember exactly which were left there. And in the case you were making, well, it started by the fact that I was just trying to build MIT and trying to see what happens if I do SFU and where it breaks. And the first thing that I encountered was that I get a KDC to crash, because the handling wasn't, well, it was quite, the actual reason of the code was quite tricky, because the MIT code was calling verify a yes request or something like that on a TGS request. So the expectation was a bit confusing. You expect to have the client, but in the case of TGS request, you don't have it. The reason the MIT does that is because service to self resembles to normal authentication. It is more like an AES request in a way, because you create a new token for a new user, not out of an old token. So that's why I suppose the MIT code used the AES request for that, but that was tricky because the AES requests are not exactly the same as the TGS request, and that caused the crash. And there was also another crash with, I don't remember. the second one was a bug in MIT, an assertion failure in MIT, which, by the way, I didn't. It's not mentioned anywhere. But this bug I also found with Samba, and the way it happened is that I started when I started the project. I added a little test, to one simple test for my work, and it worked, and I was happy. And then I don't know why exactly I did run a more complete test suite. And Samba has one of the tests that Samba runs is the Windows 2003. And in the Windows 2003 simulation of Samba, Samba disables AES keys because 2003 didn't support them. And that has triggered the flow in MIT to test actually RC4 with S4U2Self, and that got me the understanding that there is an assertion failure specifically in the all encryption types, which is quite weird. The reason why it happens only in that case. The next one is, well, the most interesting one is I worked with Andrew Bartlett, and basically it started with a pull request and a little bug fix. I realized that there was a very simple situation when I had a strange bug. If I was trying to make a request from an MIT client to a Samba KDC, by the way, this bug still exists, then what you get the checksum is keyed, but the key to open the checksum doesn't match the key, some strange error. And I figured that what's happening was that according to the protocol, the checksum type that should be used is the HMAC MD5 per spec all the time. Doesn't matter what is the encryption type you are using, you should use HMAC MD5 for the checksum. However, in Hemdal, they used the checksum type of the TGT. So in the old cases where before AES, that wasn't a problem, because before AES, most of the time you use RC4 keys, and the checksum type of the RC4 encryption type happens to be HMAC MD5. So Hemdal works fine with RC4 clients. Where it doesn't work is once you move to AES, because then the checksum type is different, but the Samba KDC, the Handle KDC expects the one that matches the TGT, but the MIT client per spec sends, and Windows client as well, by the way. And by the way, we landed the fix to Handle about 2 weeks ago, I think, or a week ago. So now Windows client can connect, but MIT client still cannot connect for another side reason, which we sure don't have the time to explain right now. In addition to that, in the discussion with Microsoft, many times I had to debug this exact same case when I didn't want to take any, because I can always use the code to prove to myself little things, but in this case I wanted to make sure that I can do it on the wire, and I didn't cheat it, and I had many bugs with my interception code. I used the firewall level IP tables to take the packet, try to combine, and it was quite difficult. So I gave it up, and I wrote a very simple interception code in Python that just get traffic from one socket to another, and then I put myself in the middle as if I am the KDC, okay? Or you can do it in many ways, DNS, IP, or whatever, and then once you get the packet, you can take the packet and use Python Kerberos API to open the packet, open the ASN1, parse the ASN1, make changes, and recompile it, re-encode it, okay? And then you send the packet on the wire. So you have the code over there. Well, this is basically it. I think there is no more slides. Thank you everyone for listening.